Okay, now we're going to go down a list of statistical tests very similar to the first group, the uh, independent test, dependent test, ANOVA, that kind of thing. But we're going to go down through a list of these that have to do with something called non-parametrics. And if you look back at that choosing a statistical test document that's in Module 4, we're talking about the things in the middle column. And there's about 3 reasons why we'd use non-parametrics. The main one is if the dependent variable or any other variable in there is not interval or ratio scale, that is, it's ordinal data, like on a survey, then we want to use non-parametrics. You can also use this if you have small groups. For example, if you have less than 25, non-parametrics is a better option because you don't have normal distributions. You don't have enough people in a group to say that it is normally distributed. Or if the data of interest or frequency counts. For example, if you're looking at misbehaviors in a classroom and you're keeping count of how many types of behaviors are occurring, those are the reasons why you'd use non-parametrics. First one we're going to look at is called a Mann Whitney U test. If we have 2 groups of subjects for which we have surveys or other measures, we might want to compare them. If the data was interval ratio and we were comparing males and female salaries, we'd use something called the independent sample t-test. The Mann Whitney is the non-parametric equivalent to that. So what we did was we had this measure called a locus control. It's a survey that we give to students. They fill this out, and we're going to add up those raw scores, and it's going to give us a measure of their locus control. And that basically means who's responsible for my behavior. If I have a low score on it, somebody else is responsible. I have an external locus control. If I have a high score, then I have an internal locus control. So you have a document called locus control that's in this folder, and you need to load that in to SPSS. And you should end up with 4 columns: grade, gender, pre-LOC, and post-LOC. And then you want to click these things: analyze, non-parametric, legacy dialogues, 2 independent samples. Something like this. So I'm going to go through here, analyze, non-parametric, legacy dialogues, 2 independent samples, and I'm going to reset this. My 2 measures over to the test variable list. The gender, because that's what I'm interested in. I'm only interested in 2 groups. Define those groups. From the options, we can select descriptives and leave that at Mann Whitney U. And hit OK, and you get some information. Now, what it's doing is it's comparing these 2 groups. It's got all these scores attached to male and female. And I want to provide an intervention, and I want to do the post-test scores later. So what I want to know is if there's a difference between males and females on the locus control, and is there a difference between males and females on the post-test. Essentially what it's doing, I'm going to go back, and you can do this, is if we took our pre-test locus control, I'm in the Excel sheet right now, I told it to sort that column from biggest to smallest. It's going to resort them. So my largest number is up here, and it kept up with the gender. The smallest number is down here. And what it wants to know is, does the score here have something to do with the gender label? If it did, if the ones who were identified 2 had all the high scores, we'd see a lot of 2s here and a lot of 1s down here. And that's probably going to mean something to us. But you can see from this, things are really scrambled up. There's 1s and 2s up here with the high scores and 1s and 2s down here at the low scores. Well, we don't want to have to figure all that out. We want the computer to do this for us. So what it's doing is it's ranking those. The average rank of those with the number 1, there's 15 of them, is a 14.17. The average rank of those with the number 2, there's only 13 of them, is 14.88. That means the ranking in this list. So there's only difference between 1 and 2 on that. There does seem to be a little bit more difference. There's more people scoring higher ranked that are A2 here than those that are A1. So the females, if we resort this column, remember you don't have to do this, you'll see a few more 2s up here because they're ranking a little bit higher on that. Again, we don't want to have to figure that out. We want it to just do it for us. This column here is called a sum of ranks. It adds up the position of all these people, what the position for when looking at the post-test for all the 2s are. So this is position 1, 4, 6, and it's adding up these numbers. And the position 2, position 3, position 5, it's adding those up. It is summing up those ranks. Now it's going to run some tests, and you get quite a bit of information here. First of all, you get something called a Mann Whitney test. This is like the F score or a T score. This is the actual test that's been conducted. It also runs something called a Wilcoxon. Don't worry a whole lot about it. You need this one right here just to keep up with. It has something called a Z score, and basically this is kind of interesting, but it doesn't really make a lot of difference. You'll notice we're comparing 1 to 2, and 1 is less than 2 here, 1 is less than 2 here, and it's quite a bit less, and this number is negative. If 1 was ranked higher than 2, and 1 was ranked higher than 2, that would be positive. So it kind of tells you what is happening with these ranks. These numbers are really what we're interested in. This is the p-value. There's 2 different ones. There's asymptotic significance and there's exact significance. Deciding on which one to use depends on a couple of things. The rule of thumb is if this number right here is less than 5, you have to use the exact significance. But really, if it can do it, it'll give it to you. If it can't, it's going to give you asymptotic significance. And the reason that this occurs is to be able to do this exact significance is really hard. It takes a lot of computer power to be able to figure this out. And basically, this is kind of this asymptotic. It's kind of a wimpy way of calculating significance. You'll see it's not quite as accurate. It's missing this a little bit. And if you remember back from math class, asymptotic means approaching significance but not quite there. By not quite there, we mean it can't really get as accurately, calculate this as accurately as we like it to. But if that's what you got, that's what you got. So because these numbers are not less than 0.05, that means there is no statistical significance between the males and the females on the pre-locus control or the post-locus control. The males are ranked slightly lower than the females. Make sure I've got that right. Yeah. And in here, the females tend to rank a little bit higher. So there's not any difference. How do you write this up? This is it right here. It's a very simple thing to write up. This is much more simple than running something like an ANOVA. You don't get near as much information as you do with it. But it's not as powerful a test. However, it is the right test to use. So that sums up the Mann Whitney U. I'm going to send out an example of one of these for you to practice on, and we'll move on to the next one.